So now we want to talk about reactions stoichiometry. And if you have been paying attention on the things we have done before, I will send some of you out now. I will send you out. Iwo, hey! Shura Amidi. You and that, well, the two of you is the last one. Since you came inside, you have been talking. That should be me. You should look front. You should sit properly and look front. The girl you are talking to is at the back. Since you came in, you have sat like that and you're talking to her. If you want to talk to her, you stand up, fly in. You must say that. You want my boy. Be turning your head upside down. So please, let's keep quiet. What we did in the morning, anybody could have done that. It's a very simple aspect. What we want to do now, only few people know how to do it. Even after being taught, only few people know how to do it. So let me still prepare your mind. It's not so hard. It's very simple. It's just combining one or two things together. And this is the same thing as only few people know how to cook. If you know how to cook, you will know the amount of salt, the amount of Maggi that will be enough for 1 cup of jollof rice compared to a plate of rice. So it's the same thing. So even if you have been taught how to cook, if you do not apply the right ingredients in the right proportion, you might still not get it right. So what we have been doing since morning has been straightforward. What we want to do now will be dependent on many things. And so please, let's make it simple. I will teach you the normal approach, then I will also teach you the shortcut method. But understanding the normal approach is what will help you to not fail in the shortcut method. You can know the shortcuts and still miss questions. But if you understand the normal approach, the shortcuts will always work. And which is always better, especially when you want to save time. So let's take our steps like the way we did it in the morning. I'll teach you the principles, then I'll give questions, then we solve all of the problems on it, self-in. So what we want to do now is called reaction stoichiometry. Reaction stoichiometry. At least we are all fasting. I've not seen food today. We saw me outside. Eating. Yes. That's how they will know who are the apropos. Apropos, how did you see me eating? Near heads. Where's the evidence? Where's the evidence? Good out. So, I said I'm not eating spoke, but we don't know anyone. We have to be around Jeff. We lost someone. Now, it's in somewhere. Everybody out there. So, in reaction stoichiometry, what we have been doing since morning is composition. In reaction stoichiometry, you have to be following some equations. You have to balance reactions before you do it. So learning about reaction stoichiometry, there's what we call mole concepts. Mole concepts. Understanding mole concepts is the introduction to reaction stoichiometry. Now, when you are talking about mole, it's just like in physics. If I say that what is the simplest unit of time, that is second. Abi? If I say what is the unit of length, that is meter. Right? Even though you can have hour for time, you can have minutes, you can have light year, you can have different ways of measuring time. But the unit of every of your calculations is second. Same thing in chemistry. You can be given mass in gram, you can be given volume in cm3, you can be given density, you can be given a lot of parameters. But the simplest way in which you approach problems is mole. So every time your brain thinks in calculation, your problems must be brought down to the mole level. Now, mole is the basic thing in this aspect. If you understand that you are given a mass, how do I convert that mass to mole? How do I convert the volume I'm given to mole? How do I convert all of these parameters to mole for simplicity? So, in a case, you are told that 3A reacts with B to give, let me say, C. So making this simple, they can now tell you a lot of things. Let me tell you the basics of the problem. They can tell you the mass of A. They can tell you the volume of A. They can tell you the concentration of A. And they will now say, calculate the mass of. They can say calculate mass of C, but they gave you the properties of A. The only information you were given was all about A. But they are now using the information they gave you for A to solve the problems for C. That's where reaction comes into play. Now, understanding this reaction can tell you a lot. If you know a lot about A, what you know about A can tell you something about B and can tell you something about C. Now, let's say this. You were told that 10 for the simplest value. I'm not saying gram now, I'm not saying cm3, and I'm not saying mole per dm3. 10 mole of A is given. If they give you 10 moles of A that will react with B to give C, from what you are given here, you can tell what the mole of B is, and you can tell what the mole of C is. And how do we tell? From what we have here, what's the ratio? 2 to 1 to 3. Abi? Now, if this is 10, what do you think this guy should be? What do you think this guy should be? Can you see the relationship? You knowing one can tell you the rest. How many tires are you supposed to have for a car? Natural, normal car. There is no toy car or trailer. For a car, you are meant to have 4 tires, Abi. So if you have 4 body parts of cars, for every car I'm going to produce, I need 4 tires. Now, I'm going to produce the car. This is a specially made car for specially made people like Emmanuel. So let's go back to chemistry class. For you to produce a car, what is the amount of tire you will always need? That means for every of these guys, you need 4 of these to produce 1 of these. Right? Let's now say that I have 16 tires. How many cars do you think I'll be able to produce? You see that the fact that your brain knows that, oh, the ratio should always be 1 to 4 to 1. Immediately they gave you 16 tires. Your brain already divided the 16 by 4, Abby, and you already know you can produce 4 cars. So if I now say, oh, how many cars did you produce? You will say 4. How did you know you will have 4? From the tires. It's the same thing here. I hope you are listening. Now, what if they just give me 5 of this guy? How many A will I have? What will be the value of A I will have? Or some of you are saying 1. From what you have seen here, this is telling you that for every time A is 2, B must be 1. Meaning that if A is 50, B must be 25. That's what the reaction is telling you. And we call this mole concept. So you understanding how mole operates, then your problem is totally solved in reaction stoichiometry. But the story I'm saying here, a lot of things can lead you there. Now, let me now take you to this. While you were in secondary school, you were told that number of mole is mass over molar mass. Abby? Now, they now give me this reaction, for example. They now say that, let me just tell you that, let's say that the molar mass of A is 16, for example, gram per mole. And I told you that, from the story I've told you here, listen, so you see that it's not that hard. You just find it difficult at times. I now told you that determine the number of moles of C produced from 32 grams of A. Now look at the problem. I've been talking about mole. Anything they give you, you have to convert it to mole. They now said, determine the number of mole of C produced from 32 grams of A according to this balanced equation. Now, what am I supposed to do? Calculate the number of mole of A, Abby. By the time I know number of mole of A, I can know about B and I can know about C. Because the ratio is already given, 2 to 1 to 3. So at the end, I'm going to say, oh, I remember the number of mole is mass over molar mass, since I am given the mass. And mass is 32 over molar mass, 16. And that will give me what? 2 mole. So if the number of mole of A I've gotten is 2 moles, what do you think is the number of mole of A? What do you think is the number of mole of C? Let's assume that the mass of A you are given is 64 grams. What would be the number of mole of A or C? Look at it, think about it. You have to allow your brain to work this time. If the number of mole I have is 64 grams, what do you think will be the number of mole of C? Eh? So yeah, let's think about it. Number of mole will be mass over molar mass. That will be 64 over 16. That's what? Eh? And the ratio already said that whenever this one is 2, this one must be what? 3 times of what this one is. So if this one is 4 mole, what do you think this one will be? It will be 6 mole. 4, 6 is the same thing as saying 2 ratio 3. Abi? It will be 6 mole. You must see it. You must think about it. You must process it. All these things, this is the major problem. And the moment you can solve this problem, you don't have problems. But it's not a problem, just take your time. We will take it step by step. So, I will solve a lot of problems. Now, another question is, there is concentration of A equals 0.5 and 0.5 molar, and volume of A equals let me say 500 cm cubed. You are given the volume of A, you are given the concentration of A. I'm going to take you back. I'm telling you that they can give you mass, they can give you volume, they can give you concentration. To make your reaction so simple, your calculation so simple, just convert everything back to mole. Now there's a formula I'm going to give you as we move on and prepare your mind. There's a formula I'm going to give you as we move on. The formula says that number of mole is equal to concentration times volume over 1000. Immediately they have given me this about A. They now said I should determine the number of mole of C. Then I want to convert what I'm given to mole first as the simplest unit. Then the concentration is going to be 0.5 times 500 divided by 1000. That's going to be what? 0.25 mole. Abi? So eventually, number of mole of A is 0.25. What do you think will be the number of mole of C? Their ratio is 2 to 3. There are ways in which you will do it without thinking, but think first. If this one is 0.25, what do you think this one should be? Yeah? 0. Do you know how we got that? This is like 2 ratio 3. You can divide this by 2. That will give you something. Then multiply by 3. That will give you this. But look at it. Look at it. You can have a problem that will give you a value as simple as this. But if you cannot see it, you might start having some bit of issues. But there are ways in which we can do it that you don't even have to think. Now, from what we have here, this is 0.25, then this is 0.35 mole. So what does that told you? That this is 2 ratio 3, Abi? What you have here, 2 times of it, 3 times of it is what you have here. Abi? If you divide this by 2, what will it give you? 0.125, Abi? If you multiply 0.125 times 3, what will it give you? This. That is telling you that this is 2 ratio 3. If you think about ratio. Now, what have I done here? I converted my concentration and volume to mole first. Then I now compare their mole. That's why they will tell you that balancing equation is very important. Imagine I did not know this. Then whatever I give will be false. So I have to learn to balance equation. So let's start. What do we mean by reactions to implementing? That's all you will be doing, you know. The moment you understand what I'm saying here, when we start now, you see that it will be clearer. So don't worry, you will get this now. Now, when you say reaction stoichiometry, you are talking about the quantitative determination. Quantitative determination of the amount of substance. Quantitative determination of the amount of substance involved in a balanced chemical reaction. Quantitative determination of the amount of substance involved in a balanced chemical reaction. Or the determination of the amount of products, or the determination of the amount of products from the combination of reactants, or the determination of the amount of products from the combination of reactants, and vice versa. Combination of reactants and vice versa. In another way, it involves the determination of unknown. It involves determination of unknown from the known. It involves the determination of unknown from the known. Unknown from the known. So in that sense, we want to quantitatively determine something, calculations that we have been doing. When I said something about A the other time, I said from this balanced equation, if A is 50, or let's say if A is 10, in this place now I know A, then I use A to determine C and to determine B. If A is 10 here, A is described as my known, is the one that I know. Then the one that I do not know is B and C. But from the balanced equation, I can tell what B and C is. So I can use the known to determine the unknown. That's the definition I've given you. Now, from this balanced equation, their ratio is 2 to 1 to 3. And we said it. If this is 10, what do you think this would be? 5. What do you think this would be? 16. Do you get that? So, we have used this known now to determine the what? The unknown. Now, right. In reaction stoichiometry, a balanced chemical equation. In reaction stoichiometry, a balanced chemical equation is required. A balanced chemical equation is required. So before you solve problems in reaction stoichiometry, you have to know how to balance equation. There are two methods we use in balancing equation. I'll teach you just the first method, we move on. The second method might not be needed for now, so that we don't waste time. Now, I said in reaction stoichiometry, a balanced chemical equation is what? Is required. Abi, is needed. So, they can ask you, what do you mean by chemical equation? the definition for chemical equation, right? A chemical equation is defined as the symbolic representation. A chemical equation is defined as the symbolic representation of a chemical reaction. Symbolic representation of a chemical reaction using chemical formulas. Symbolic representation of a chemical reaction using chemical formula. Then we call it a balanced chemical equation. So, someone asked this question that, but sir, if your value is in, I can't see this, is in DMQ, that means that if the value of the volume they gave here is DMQ, then you won't divide by 1000. If they give you this one to be DMQ, DMQ is the units, you don't divide by 1000. But if you are given a CMQ, we will still talk about it. We have not gotten there. This one is just a bit of story that some of you don't know about before. So I only said it just to prepare your mind that what we want to do is not hard, but you might just need to think a bit. It's not hard. And sometimes even when you know it, you don't even need to think. For what I was doing here the other time, there's a method I would have used to get my right answer. So but let's just manage. So I said a chemical equation is defined as what? Symbolic representation of a chemical reaction using chemical formulas. So meaning that I can say H2 plus O2 to give me H2O. So this is a chemical equation. So this equation now, oxygen is going to react with hydrogen to give water. So this is a chemical formula, a chemical formula, a chemical formula. So the symbolic representation of a chemical reaction using chemical formulas is what we call chemical equation. Now, paragraph. A balanced chemical equation obeys the law of conservation of mass. A balanced chemical equation obeys the law of conservation of mass. After teaching you how to balance chemical equation, then we are going to state the law of chemical combinations one after the other. A balanced chemical equation obeys the what? Obeys the law of conservation of mass. Mass. That tells you that the total mass you are putting in will be the same as the total mass you are getting out. I'll get there. I'll come back to that. Just note that statement. Now, how do we balance chemical equation? We balance chemical equation using two methods. So, two methods of balancing chemical equations. So, what are the two methods of balancing chemical equation? The first one is called inspection method. And that's the one I will just spend my time on here. The second one is called simultaneous equation. Because of time. You can use inspection method or simultaneous equation to balance equation. But in your JAMB, you won't even need this at all for any reason. You won't need it. But you might just learn it. And during post-UTME, you can still learn it. Or if there is still time. But inspection is what we do most times. And how do we do inspection? You have been given this. The hydrogen reacts with oxygen to give you water. How will you balance it? Then you look at it. Inspection method means observe and tell. Look at it, investigate, and tell me what it is. How many hydrogen do I have here? 2 by inspection. How many do I have here? 2. You can see, Abby. So hydrogen is okay from inspection, ordinarily looking at it. How many oxygen do I have here? Is oxygen balanced here? No. So what do I do here? Balance. Don't now make mistake to add 2 here. If you know chemistry, you're already talking about something different. This is no longer water. This is hydrogen peroxide. So when you are balancing equation, don't change the subscripts for any reason. Are you following? So you already know this guy needs 2, then you will put 2 at the front as inspection. Then what do we have? Is it balanced now? No. What has changed? Hydrogen. So now, that means that I can have 2 again here. Is that okay now? Yes. That means this is saying 2:1:2. So if this guy is 10 mole from your calculations and all your stories, what will this guy be? What will this guy be? I hope you are following. Don't worry, step by step. Now, what does the law of chemical combination, law of conservation of mass now states? You can see that my equation is balanced now. We said something that a chemical equation that is balanced obey what law? Law of conservation of mass. Let's see how that law applies. Hydrogen, the atomic mass for hydrogen is 1, Abi, and there are 2 of it. So you will put 2 outside and you will say 2 times 1. Do you understand what I've done here? 2 times hydrogen is 1, Abi, and there are 2 of it. So you say 2 times 1. Then that 2 that is here will be outside. Do you get that? So at the end, that will be what? 4 altogether. So that will be 4 grams. Let me rewrite that. I want to take it step by step. That's why I'm doing what I'm doing. So 2H2 plus O2 to give 2H2O. So how does this obey the law of? This is a balanced equation, and our rule states that a balanced equation obeys the law of what? Conservation of mass. So now, from what you have there, you put the 2 outside. Hydrogen atomic mass is 1, Abi. Then how many of it will you have? 2. So times 2. So that will give you 4 grams, Abi. Yes. For this now, how many do you have here? That's going to be 16 times 2, Abi. That gives you what? 32 grams. Then on the product side, you put the 2 outside. You have to, you remember what we have been doing? How to calculate molar mass. 2 times 1 plus 16, Abi. 2 times 1, 2 plus 16. So everything 18 times 2. So if you look at this now, the total mass on the left hand side is equal to the total mass on the right hand side. And that is why we said a balanced chemical equation obeys the law of conservation of mass. The total mass you put in will be the same as the total mass you will get out. That's a JAMB question for you. Question number 1. You have not started. But that's a question they can ask you in your JAMB. A balanced chemical equation will be what law? Law of conservation of mass. And they can ask you that what does the law of conservation of mass states? We will talk about it. Matter can neither be created nor destroyed, but can be transformed from one form to another. That's the law of conservation. We will talk about it when I get to law of chemical combination soon. So now, I hope you are getting to this level. We have not started. It's the introduction. So, we balance by inspection. Oh yeah, everybody. Nitrogen reacts with hydrogen. They always put their states, but not to waste time, I might not be showing you the states. To give ammonia. Can you balance the equation and show how it obeys the law of conservation of mass? Balance the equation by inspection and show how it obeys the law of conservation of mass from what we have been doing. I'm doing this for the sake of those that are just learning, so that you take it step by step, one step after the other. So nitrogen gas reacts with some hydrogen gas. This is actually a reversible reaction. to give ammonia gas. Balance the equation by inspection. Even the complicated ones that you can't really balance by inspection, you can use your options to tell. So the simultaneous, if we start that now, some of you will be so worried about that. And at the end, what you are supposed to learn, you will not learn. So I'm not here for Senere for now. You are here for what will come out in the exam. Map, do it, and move on. Are you there? Have you balanced the equation? What is the number of mole of nitrogen here? Nitrogen here. Then this one. Is the equation balanced? That means that 2 nitrogen here, 2 nitrogen here, Abby. 6 hydrogen here, 6 hydrogen here. Is that taken? So that means the equation is balanced. So can we check if it obeys the law now? This will be 14 times 2, Abby. That's 28 grams. Do you know I got that? It's what we have been doing since morning. This one is 2, but times 3. That's 6 grams, Abby. This will be what? 14 plus 3, that's what? 17 times 2. Is that 34? Yes. So yeah, check. 28 plus 6 is what? 34. Why the product side is also 2? So you can see. So if your equation is balanced, it obeys the law of conservation of mass. Are you there? So everybody should be able to balance ordinarily by inspection. SS1, magnesium plus chlorine gives magnesium. No, let me do this. Let's balance this one. Magnesium plus HCl. This gives me MgCl2 plus H2. Then don't beat yourself up again. Sometimes you look at some reaction and you be like, how do they know that it is MgCl2 we should give? It is H2. Yes, as a learner you might start asking those questions. But if you have learned chemistry almost to the end, you will know most of these reactions normally. There is a reaction that says that acid reacts with metal to liberate hydrogen gas. But have you done acid, base and salt? No. Have you done it? No, you have not. To those of you that are just learning or just joining. You have not done acid, base and salt. So you might be thinking, how did I know it's hydrogen gas that is produced? So now balance this by inspection. What will you have? Mg plus HCl. Is that okay? Yes. Is that taken? That's the first thing. Now that you know how to balance equation, then let's look at what we now call mole concepts properly. Mole concepts. So, I didn't teach you this. You can learn it later. It's not so hard. I don't even want to waste time. I would have used this to quickly explain it. I can explain it to you later if you want me to. But there are some things that might just be a waste of time for exam students. So, now, what do we now mean by mole concept? A mole is defined as the amount of substance. A mole is defined as the amount of substance that contains as many elementary particles elementary particles as there are in 12 grams of carbon 12. As there are in 12 grams of carbon 12. That's how you write it. In 12 grams of carbon 12. You remember, number of mole is what? Mass over molar mass. Carbon is what? 12, Abby. So if I have 12 grams of carbon 12, that's 12 by 12, that's what? 1 mole. The simplest units. Don't worry. So now, the amount of substance that is present in a substance as they have in 12 grams of carbon 12 is what we define as mole. 12 grams is just taken as a standard. 12 grams divided by 12 will give you 1 mole, just like a standard. So now, let's now look at this. What does this mean? 1, note this. 1 mole of a substance, 1 mole of any substance, 1 mole of any substance contains the Avogadro's number of particles. 1 mole of any substance contains the Avogadro's number of particles. Don't worry, we need notes here. It can be summarized. I'll just jump to the questions and solve. 1 mole of any substance contains what? The Avogadro's number of particles. So you write, Avogadro's number is represented as n sub A, and that is given as 6.02 times 10 raised to the power 23 particles. If you don't know what the particle is, we can talk about it. 1 mole of any substance contains Avogadro's number of particles. Now, this is what this means. And the simplest analogy is that if I tell you that 1 dozen, what comes to your brain? If I tell you 1 dozen, 1 dozen of sweets, that means I have 12 sweets. If I tell you I have 1 mole of substance, what do I have? That means I have 6.02 times 10 raised to the power 23 of that substance. It's just a unit, simplest unit. Don't be lost in the crowd. 1 dozen, the same way you know that 1 dozen is 12, is the same way you should know that 1 mole is 6.02 times 10 raised to the power 23 times. So if I say 1 mole of sweets now, that means I have that sweet 6.02 times 10 raised to the power 23 times. So if you start counting, and which is some billions of trillions, but in a standard form. You know, this one can be written as 602 0 0 0 0 0 0 0 0 0 0. So the number of zeros goes to like 23. So you can see how much when you say 1 mole of something is. If I say 1 mole of all of us in this place now, that means the total population we have here will be 6. Nigerian population is just like 200 million. This, I cannot even pronounce this. Already, if you already have this, that's even more than 6 figures. This is 6 million, I mean. Eh? 602,000. 602 million, I mean. Is that correct? That's 602 million. 602 billion. So you can see. And we are going to 23 zeros. So how do you keep saying that? So you have zillion, quadrillion, and so on. So, but for now, I pray I have this morning. So please, the problem is just that if I say, look at this now, these are the concepts I want you to get here. If I say I have, because all these simple things, no matter what are there, in stoichiometry. These are the things that used to cause issues when you are dealing with stoichiometry. I say 1 mole of any substance. If I say this is a pregnant woman, This pregnant woman has 2 children, and I have 1 dozen of those pregnant women. 1 dozen of those pregnant women. How many are the pregnant women? 12 pregnant women. Well, if I now say that, how many are their children? I hope you are following. It's the same thing as what we are saying here. If I say 1 mole of pregnant women, how many pregnant women do we have? 6.02 times 10 is about 23 pregnant women. That's the unit. Abi? Now, each of the pregnant women carries what? 2 children. How many children do you think all the pregnant women carry in total? Eh? So that means we multiply that value times 2. I hope you are following. Please. When I said I have 1 dozen of pregnant women, I have 12 pregnant women, Abi. When I say how many children, just multiply the 12 by 2. Abi, so if I say I have 1 mole of pregnant women, you already know this is the total number of pregnant women. Then each pregnant woman carries 2 children. Then if I now say how many children are they carrying, that will be times 2. I hope you are following. So now let's go back to chemistry. If I say 1 mole of Na2CO3 contains what? What does that statement mean? 1 mole of Na2CO3. To you, what does that mean? .02 times 10 is about 23 Na2CO3. That means the total number I have this guy is 6.02. I hope you are listening. Yes. If I say 1 dozen of this guy, how many times do I have this guy? If I now say 1 mole of this guy, how many times do I have it? 6.02 times 10 is about 23. But I now ask you, how many sodium ions do I have? Each of these carry how many sodium? If I now say that in this place, for 1 mole of this guy, what is the total number of sodium ions? What will your brain say? If 1 mole of this guy is 6.02 times 10 is about 23, then and I have 2 sodium ions in 1, then that means that the total will carry 2 sodium ions. Then I will multiply that value by 2. That will give me the total number of sodium ions. I hope you are listening. If I say that how many oxygen atoms? You can see my statements. How many oxygen atoms will I have in this place? That means I'll multiply 3 times this value. If I say I have 1 dozen of this, that will be 12. How many sodium will I have in that 1 dozen? That will be 2 times 12, Abi. That will be 24. Abi, how many oxygen atoms will I have in 1 dozen of this guy? That will be 3 times 12 because I have this guy 3 times in 1. I hope you are following. It's simple, it's not hard. But it's just that it will be required in dealing with problems. When you start solving some problems, they might say calculate. But all of these stories I'm saying, they are coupled in some formulas. But there are some questions students miss, and they feel like they have solved it right. It happens a lot in stoichiometry. All because they did not understand the concept. That's why we call it no concept. So now that you know this, that 1 mole of any substance contains this Avogadro's number of particles, then the second statement. One mole of a gas at STP contains 22.4 dN³ of the gas, or 22,400 cm³ of the gas. 1 mole of a gas at STP contains 22.4 dN³, or 22,400 cm³ of the gas. Is that taken? Don't worry, I'll give you the formulas. You just solve some 1 or 2 questions. We will still come back to it again because we have a lot to learn there. But there's nothing much. So now that you understand these 2 statements, I'm supposed to teach you something next, which is limiting and excess reagents. I'm going to hold on for that. Let's solve 1 or 2 problems. So now, when you're talking about mole concepts, you need to know this formula. Your mole is the simplest from what we have said. So these are the formulas you need to know. 1, number of mole is equal to mass over molar mass. So even if you are just starting, you shall know these formulas. It's not everything you use this formula for that you have to balance equation. Roman figure 2. Number of mole is equal to concentration times volume over 1000. This is if the volume is in cm cube. If the volume is in cm cube, you will divide it by 1000. We are going to solve all of the questions together before I start complimentary. So, because I can just teach you and you might still have issues. So we solve them together. But you try your best. Number 3, so I'll show you that you might use your formula and you might not even use your formula in calculations. Number of mole is also equal to volume. Are you true? Are you true? Note these formulas. I've given you that PV is equal to nRT, Abby. Now, you keeping this formula in your brain, understanding what I've said here, and understanding how to balance equation, then you have no problem. So, let's take some basic examples. Whatever you do, always work towards the mole. Whatever you do. So all you just have to think about is that if I say calculate the mass of hydrogen gas liberated at STP, calculate the mass. The question already said calculate the mass. And I told you the last time, the moment you hear calculate the mass, which formula am I using? That's where your brain will go. That means I will use the first formula, Abby, because they say calculate the mass. The next question is, if I'm to use the first formula, how will I get this? How will I get this? Let me give you a question. Let me first give you this one. That will solve it. So now, drill. 44 grams of magnesium, 44 grams of magnesium reacts completely with HCl. What is the mass? What is the mass of hydrogen obtained at STP? Mg equals 24, H equals 1, Cl equals 35.5. So the question says that what is, as I'm solving it, I'll also try and be solving using the shortcuts for you. But you have to be careful of that shortcut because I've not taught you limiting and excess reagents. I'll show you why I say you should be careful of the shortcuts. 44 grams of magnesium reacts completely with HCl. What is the mass of hydrogen gas obtained at STP? Now, the question is this. What is the mass of hydrogen gas? So where will your brain go to? First formula, Abby. So you will say that, oh, solution. Number of mole of hydrogen gas is going to be mass of hydrogen gas over molar mass of hydrogen gas, right? Meaning that mass of hydrogen gas is going to be number of mole of hydrogen gas times molar mass of hydrogen gas. It's very easy to get the molar mass of hydrogen gas. That will be what? Is what we have been doing. To calculate molar mass, that will be you have 2 hydrogen, so that will be 2 hydrogen. That's all it's involved. So that will be 2 into 1. So that's what? 2 grams per mole. So the molar mass of hydrogen gas is 2. But now, do you know the number of mole of hydrogen gas? You know what you are looking for is the mass, Sabi. You can calculate the molar mass. That's this one. Is that taken? But now, do you know the number of mole? Do we know the number of mole from the question? No. How do we know the number of mole is your next question. You will ask yourself. And from what you have seen here, you must balance the reaction. Abi, you are going to react magnesium with what? With HCl to give you hydrogen gas. And reaction stoichiometry says that you can use the known to look for the what? Unknown. My known here is magnesium. I can use what I know about magnesium to determine what I do not know about hydrogen. Only through a balanced equation. Abi, oh yeah, let's balance the equation. That's the next thing. So how do I balance the equation? You react magnesium with HCl, Abi, to give me MgCl2 plus H2. There will be 2 here. Abi? So from what you can see here, what is my problem in this place? What do you think is stopping me from moving on? Please be talking. We have to start doing this together, especially this aspect. It's not hard. What is stopping me is just what? Number of mole of hydrogen. So the question is, how do I get it? Then I can get it here. Then the next question is, if you want to get the number of mole of hydrogen, you can know the number of mole of magnesium. This is a balanced equation. The number of mole of magnesium can tell you what hydrogen is. How do I know number of mole of magnesium? Is the next question. How do I know number of mole of magnesium? Because we are given mass, Sabi, then you can do mass over molar mass too to know that of magnesium. Is what we are doing, is it that hard? So now, let's determine the number of mole of magnesium so that we can use it to determine the number of mole of hydrogen. That's why I started from where I started from, but I'm not just jumping into it. So that your brain will later follow. So now, let's get the number of mole of magnesium. Number of mole of magnesium is going to be mass of magnesium over molar mass of magnesium. Are you there? So number of mole of magnesium is mass of magnesium given 44. What's the molar mass of magnesium? 24, Abi. So 44 divided by 24 is what? 1.83 mole. So the number of mole of magnesium is 1.83. So let's now see what that is saying. If this one is 1:1:1:2, so the question is now, if this one is 1.83, what do you think this one will be? You multiply by 2, we don't need it. So you know the one we need is hydrogen. I'm just saying that since I know this now, I can know this, I can know this, I can know this. So if this one is 1.83 mole, what do you think this one will be? 1.83 mole. Who does not understand how we got to that level? We have not done anything strange. Please. Do you understand that? So now that you know the number of mole of hydrogen, you can now calculate the mass. Abi? And what does the formula state? Mass is equal to number of mole times molar mass. So you now say that mass of hydrogen is equal to, what's the number of mole now? 1.83 times what's the molar mass of hydrogen gas? 2. And that will give you what? 3.67 grams. Do you understand what we just did? Please, take your time, take your time. It's not that hard. I'll give you another question now. We'll try it again. Can we move on? If you have a question, you can let me know. Then don't close your mind. Don't close your mind. Might be soon at that. Well, I went good. And that's what's your water bed? So are you there? So look at what we have done. They said I should calculate mass of hydrogen. So your first step is know where you are going. That's the first step. Second step is how do you get there? Abi, by what means? So where am I going? I want to calculate mass of hydrogen. How will I get mass of hydrogen? My brain will think about this formula because it's the one that relates mass. Then when I now know the formula, then do I have these two? If I have them directly, I'll just solve it. But if I don't have them, then the next question is, I know this. How will I know this? Oh, that's why they gave me this. Then you use this to calculate number of moles. Then check it out and you determine your answer. If I say calculate the mass of HCl now, what do you think your answer will be? We have got the mass of hydrogen gas. So what will be your answer if I say calculate the mass of HCl that reacted with 44 grams of magnesium? Oh yeah, try that. You have gotten the mass of hydrogen. So yeah, at SCP and mass of HCl. So I'll show you the shortcut quickly for this one. We call it mass to mass relationship. That's what your secondary school teacher must have also taught you. Mass to mass relationship. Just to give this one, gives this one, then X will give this one, plus multiply to get answers. Oh yeah, everybody. Everybody should try that. 133.5 grams. Did you all get that? What did you get? It's okay to get something wrong. I don't know if they are correct. I don't know if you are correct. But if I hear different answers, then I will solve it. Then we'll look at who got it right. If I have to get mass of HCl, which formula will I use? This, Abi. That means that I need to know number of mole of HCl. What will be the molar mass of HCl? We have calculated that, Abi. HCl is going to be 1 hydrogen plus 1 chlorine. Abi, that's 1 plus 35.5. And that's going to be 36.5 grams per mole. So this is the molar mass of HCl. Abi, then I'll use my formula. Mass is equal to number of mole times molar mass. Now, from what we have here, what do you think number of mole of HCl is? Because the ratio is 1 to 2. So if this one is 1.83, then this will be multiplied by 2. That will give us what? 6 mole. Do you know how this one became 3.6? Because it's 1 ratio 2. Tẹ́lẹ̀ bá jẹ́ 5, eléyìí máa jẹ́ 10. Àbí? Tẹ́lẹ̀ bá jẹ́ 30, eléyìí máa jẹ́ 60. So tẹ́lẹ̀ bá jẹ́ 1.83, eléyìí máa jẹ́ 3.66. Do you get it? So at the end of the day, that will be 3.66 multiplied by 36.5. And that will give you the answer. What's the answer? 1,000,000.59 grams. Please, it's not hard. Don't beat yourself up. Is this okay? I'll give you another question that you are going to tell me your own answer. It's not hard. Just know these formulas. So let me now take you back to the shortcut. Please, this shortcut only applies if you are given just one of the reactants. When they give you 2 of the reactants, don't just dare to use that shortcut. So, can I rub the board? So this is how you would have done it. So after you balance the equation, Mg plus 2HCl to give MgCl2 plus A2. then you will now say that 44 grams of, or you will say, what's the molar mass of magnesium? 24, Abi. If 24 grams gives, what's the molar mass of hydrogen? 2 grams. Abi? Mass to mass, law of conservation of mass. If 24 grams of magnesium gives 2 grams of hydrogen, then 44 grams will give how many grams? So X is going to be 2 times 44 divided by 24. What's that? 3.67 grams. So that's your answer. So you can see, you don't have to, is that not what we got? Yes. So you can do mass to mass relationship. So this is called mass to mass relationship. But it has time that you use it. But yeah, let's look for that of, if it is for HCl, how do you do it? You will say that Ng plus 2HCl to give NgCl2 plus H2. At least between this and that one, and this one is faster. You might not even need to write anything down before you get to answer. Or like that first one, like we say number of mole, number of mole. But if you are not careful, number of compare immediately to mass to mass, you will get an answer. That answer will be the option. That's why you have to know what you are doing. Is to know what you are doing. You can use this anytime, but know what you are doing. So let's solve for, in this case now, molar mass of this will be what? 24 grams, Abi. If 24 grams reacts with, you will put 2 outside, Abi. 1 plus 35.5, that's 36.5, Abi. Do you understand this? You understand what I've done here? Since there's 2 here, you multiply it. Then you now say 44 grams will give how many grams of HCl? Then now the X gram is going to be 44 times 2 times 36.5 all over 24. And that will give you what? 133. So that will give you 133.5 grams. Can you see how fast that can be? We call that mass to mass relationship. Don't worry, I promise we'll solve all those questions even before I move to the next class. We'll solve all the questions together before we move on to the next class. But you can go and try your own. So if you have a problem, you can let me know. I'll solve that problem one of you gave me before we leave. But let me give you one question now for you to solve. I'll still teach you limiting and excess. But let's understand this first for starters. So next question. I'll use this same equation. Magnesium reacts with 0.5 molar magnesium reacts with 0.5 molar HCl. Magnesium reacts with 0.5 molar HCl of volume 500 cm cube. Magnesium reacts with 0.5 molar HCl of volume 500 cm cube. Or volume 500 cm cube, full stop. What is the volume of hydrogen gas obtained at STP? What is the volume of hydrogen gas obtained at STP? Question mark. What is the volume of hydrogen gas obtained at STP? So now, what are we trying to do here? I told you that first thing is, where am I going? What did they ask me? What did they ask you to do? Calculate the volume of HCl, Abi. I mean, volume of hydrogen gas at STP. That's the first thing. Please, I hope you are listening. I wish I know all of your names. I've not just been asking for names these days. Because there are some of you that just want to call your attention. from all your playfulness. Now, the volume of hydrogen gas at SSCE was the question they asked me to, was the thing they asked me to do for. Then what will your brain think next? Which formula will I use? Abi? So out of all the formulas I listed, n is equal to this, n is equal to this, n is equal to n. Which formula will help me? The third one. Abi? Now the next question is, I already know this is the formula. This is what I'm looking for. So, do I know molar volume? Molar volume is a constant. If the option is in dmq, then you will use 22.4 dmq. If your option is in cmq, you will use 22,400 cmq. Are you there? So yeah, everybody now, I already know this. I know this is what I'm looking for. I know this, but do I know this? No. How do I know this? I can know it from other parameters. What else were you given? Concentration and volume of HCl. Abi? HCl. So meaning that, I already told you magnesium reacted with HCl. That means this equation is what you need. So that thing you are given is to determine the number of mole of HCl. Now that you have concentration and volume of HCl, to determine the number of mole of HCl, which formula will you use? The second equation. So that will give you the number of mole of HCl. Now that you now have the number of mole of HCl, then you can know the number of mole of hydrogen. And you now use it to solve for the volume of hydrogen. Is the English too much? Some answers are by default. Please, do you understand what you have said? Oh yeah, try it. If you are just learning, you can list out the parameters. Oh yeah, what were you given? Concentration of HCl, Abi. That's what? 0.5 molar. Volume of HCl is what? 500 cm3. Then you have to calculate what? Volume of hydrogen gas at STP, right? So the first thing is, they say calculate volume of hydrogen gas. You already know the formula you will use. That means we say number of mole of hydrogen gas equals volume at STP over molar volume. So the volume at STP is now going to be number of mole multiplied by molar volume. Now, from this problem now, I know my molar volume, which is 22.4, but I don't know the number of mole. So how do I know the number of mole? I can know it from HCl. That's why they gave you something about HCl. And you know, number of mole of HCl is going to be concentration of HCl. I'm using this formula now. Times volume of HCl over 1,000. I'm dividing by 1,000 because the unit here is cm3. So number of mole of HCl is now going to be concentration of HCl, that's 0.5 times 500. That is 0.25 mole. Now that you know HCl to be 0.25, then let's balance the equation. I hope you are going. Now, the ratio between HCl and hydrogen is what? 2:1. You now want to use this one to determine this one. You already know this now, which is 0.25. What would this one be? Ìkọ̀tẹ́lẹ̀ bá jẹ́ twice, ilé gbọ́dọ̀ jẹ́ 1 àbí. So if this one is 10, this must be 5. So if this one is 0.25, this one will be divided by 2 àbí. That will be what? Do you understand that? So that means that the number of mole of hydrogen gas is this, and the number of mole of HCl that reacted is this. Show ye bẹ́ẹ̀ yẹn. So yeah, let's take it here now. So we can now say that volume of hydrogen gas is equal to what? 0. That's the number of molar. 0.125 times molar volume. And that will give us what? Yeah? So the volume of hydrogen gas is going to be 2.8 dm. Eh? Are we? I did not hear you. How did we know it's 6,400?
How we know you see? Why we know you see?
Then I said it depends on the option. If your option is in DMQ, most times it's usually in DMQ. If it's DMQ, you will use 22.4. If it is in CMQ, you will use this one. So it's the option that will tell. If your option is in CMQ, you multiply this one. If your option is in DMQ, so I'm assuming you can see my final answer is in DMQ. But if you use 22,400, then your final answer will be in CMQ. It's just the difference. Any other problem? Please, do we understand this? It's not hard. There are a lot of problems to solve. Just know where you are going and how to get there. Now, let me solve the problems one of you asked when we started the class. Now, it's the same concepts. This problem I want to solve. So it's the same concepts for this, but it just requires some of your understanding of inorganic chemistry. That's the thing about the question. So let's solve it together. Can I rub the board? This question says that, please don't forget, I want to teach you law of chemical combination. You can take that to next class. So what time are we meeting tomorrow? Meet by 10 tomorrow. Meet by 10 tomorrow. So to buy paper for a short Are you ready? Let's solve this one, then we can go home and rest a bit and practice some of these things again. So when we see tomorrow, we'll do more, then we'll practice more questions. So right, 3 grams, 3 grams, 3G, 3 grams of a mixture of calcium oxide, 3 grams of a mixture of calcium oxide and calcium trioxocarbonate 4. 3 grams of a mixture of calcium oxide and calcium trioxocarbonate 4 was heated. 3 grams of a mixture of calcium oxide and calcium trioxocarbonate 4 was heated to a constant mixture. Calculate the percentage of CaO in the original mixture. Calculate the percentage of CaO in the original mixture. I don't understand it, please explain it, sir. Don't write down. So let's see. Always understand where you are going. When you know where you are going, the other questions will be easier. Where are you going? LLE. Where will you take to LLE? But if you don't know where you are going, you can't tell where you will take there. So one thing about stoichiometry is know where you are going. Where are we going here? What did they say you should calculate? Percentage of CaO in the mixture, Abby. And if I'm to get percentage of CaO, that means I'll know something about CaO over the total 600. Abby? listen, So, if you are to calculate percentage of CaO in the mixture says that CaO plus CaCO3. That's the mixture. So that means you need to know mass of CaO over mass of total, Abi, times 100. Do you agree with this formula first? So now that you know what to do, the next thing is how do you get there? They already told you that 3 grams of the mixture, say they already gave you this. The problem now is how do you get this? When you know this, then your problem is solved. So, let's see. They said that 3 grams of the mixture, so mass of the mixture of these two guys, because that would be 3 grams minus whatever this one is. Shake it, then I will find them. But now, to know mass of CaCO3, if I want to know mass of CaO, what will I do? I will say 3 grams minus what? Mass of CaCO3. But do I know mass of CaCO3? No, that's another problem. How do I know mass of CaCO3? I can say number of mole of CaCO3 is equal to mass of CaCO3 over molar mass of CaCO3. I hope you are following. Now, can I know the molar mass of CaCO3? Yes. Do I know the number of mole of CaCO3? No. How do I know the number of mole of CaCO3? It's another problem. Yes. As you are getting, you already look at the problem here. They asked me to calculate percentage of CaO. I already know that what I'm going to do is mass of CaO over total mass times 100. It's the final answer. So now, you already know what you want to do. The problem now is that when I wrote this, I want to know this. I know this, I now do not know this. Problem again. How do I now know this? Then you go back to this. I hope you are seeing it. It's no hard. So when you come back to this, the formula says that CaCO3 on heating gives CaO plus CO2. But note one thing, I want to know the number of mole of this guy. The equation is balanced. So this is 1:1:1. But remember something, they gave you mass of CO2. And what do you think they want you to use that to do? So that you will know the number of mole of CO2. And when you know the number of mole of CO2, you can know the number of mole of CaCO3. When you now know the number of mole of CaCO3, you can know the mass of CaCO3. When you now know the mass of CaCO3, you can now know the mass of CaO. Yeah, you can now know. So you can see that it's a journey. Yeah? Do you understand the point? So, that's stoichiometry. You are the one that will just be knowing what you are doing. So the moment you know where you are going, that's enough. It's easy to get to LA now because it's just one car that will get you there. I don't know if you are coming from Apete, but if you are coming from Mokola, I know that you will either take Lugbe, Abi. The way you get to Lugbe, you now take LA, or you take Songo. When you get to Songo, you now take LA, Abi. Is there an LA car directly from Lugbe? From Mokola? Oh, Mama Londa, Jericho, Abi. So now, to know the mass of, what's the mass of CO2 given? So to know the number of mole of CO2 now, which formula will I use since I know mass? Number of mole is mass over molar mass, Abi. And that will be 0.44 over, what's the molar mass of CO2? 44, Abi. That's C plus 2 into O, Abi. That's 12 plus 2 to 16. And that's what 44 grams. Is that taken? So now I can say over 44. What would that give me? So let's start from back. If this one is 0.01, what would this one be? as simple as that. So you have solved the problem of this place. Is that taking? Now that you have solved the problem of this place, so what do we do now? You now put 0.01 here equals mass of CaCO3 over molar mass. What's molar mass of CaCO3? 100. Let me show you that. CaCO3 is going to be Ca plus C plus 3 into 2. That's going to be 40 plus 12 plus 3 into 16. And that's going to be 100. Are you okay? So now that will be over 100. So that means the mass of CaCO3 is going to be 100 times 0.01. So mass of CaCO3 now is 1. Then I can get mass of CaO. So I can now say mass of CaO is 3 minus 1. That will be 2. Then I cannot get percentage. I can now say that percentage of CaO is equal to 2 over K. What would I give you? You can see how simple it is. There is nothing you have done that is different from what I've told you today. It's just where am I going? How do I get there? But don't worry, the journey can lead to another journey. But the problem now is that if the journey leads you to bandits, or you can go back home. So as much as possible, from all the things we have done today, before tomorrow, as much as possible, go and practice everything you have in your past question. How many questions do you have in your past question? 100. So go and practice them. You can do it with a group of persons. You can do it alone. Please, so that when I come tomorrow, you can tell me the ones you can solve. Then I will help you solve them. Is that taking? Because if you wait for me till tomorrow, you are just delaying us. So that in a short time, I'll just explain the meeting and excess. Then I will explain the Lusak's law. So please, the Muslims are I don't know who asked this question. This is not a question. He said that I hope this kind of questions will not come out to